Hey everyone, this is the last video for revisiting our skills necessary for success in our unit on redox. Number 18. Given the balanced equation representing a reaction occurring in an electrolytic cell, we have two sodium chlorides that are liquid, producing two sodiums as a liquid and two chlorines, or one molecule of chlorine, Cl2, a diatomic element, as a gas. Where is the sodium liquid produced in the cell? Well, we need to refer to the red cat and ox after we assign the oxidation numbers. Chlorine uncombined is, grab the pen, is going to be 0. Sodium uncombined is 0. Chlorine, when combined with sodium, is going to be -1, while the sodium itself is a +1. So what is happening to the sodium? Sodium is going from +1 to 0. In order to do that, you must gain an electron. We are seeing from +1 to 0, a reduction in the oxidation number. So two of these mention reduction, that's here and here. Now where does reduction occur? Reduction happens at the cathode. Choice number 4. Alright, numbers 19 through 22 relate to this information, the picture and this, which states a student constructs an electrochemical cell during a laboratory investigation. When the switch is closed, electrons flow through the external circuit. The diagram and equation below represent this cell and the reaction that occurs. So when this switch is closed, the electrons will flow through the external circuit, which is the wire. You're going to have to determine in which direction, from the aluminum electrode to the nickel, or from the nickel to the aluminum. That's to be determined later. This question says, state in terms of energy why this cell is voltaic. I will disclose the answer up here. And here I wrote, it is that voltaic cells are spontaneous redox reactions that produce electrical energy. And that's why that voltmeter is there. It is going to actually read how much electricity is being produced. Number 20 relates to the same illustration, same circumstances, and it says determine the number of moles of aluminum solid needed to completely react with 9 moles of nickel plus 2 aqueous ions. For that, let's investigate or inspect the moles of each of the reactants in each of the products. Here we have 2 moles of aluminum reacting with 3 moles of nickel ion, producing 2 moles of aluminum ion and 3 moles of nickel. Now that is a 2 to 3 ratio, producing a 2 to 3 ratio. This is saying what happens if we bump it up to 9 moles of nickel. Nickel was this position, so if that were 9, well, that's triple the amount. This would be 6. Tripling everything here, that would be 6, and that would be 9. And the question is asking us to talk about the number of moles of aluminum solid, which is this position here, meaning that's the answer. It is 6 moles. Now number 21, also for the same scenario, asks us to write a balanced half reaction equation for the oxidation that occurs when the switch is closed. Let's once again assign the oxidation numbers. Aluminum uncombined is 0. The nickel is already given to you, the aluminum's already given to you, and this nickel is 0. Now we are looking for oxidation. Remember, Leo says Ger. The Leo is the loss of electrons, is oxidation. So we are looking for the one that goes, loses electrons, so the oxidation number climbs, gets larger. and it is for the aluminum. So let's write the half reaction for that. We have two aluminums, oxidation state of 0, that is a solid, and it is becoming two aluminums with an oxidation state of 3 plus. The question is, right here, right now, is it gaining electrons or losing them? And it is losing the electrons. So we would not write it on this side right here because that would suggest that it was added to the aluminum and it's gaining it. So we must put the electrons over on this side because it is now being separated. Now the question is, how many electrons? Well, each aluminum would end up losing 3 electrons, but we have 2 of them. We are looking at a loss of 6 electrons. There it is. Alright, 22 is also for the same scenario, and it's asking us to state the direction of electron flow through the wire when the switch is closed. So here's the switch. Our electron's going to go from the aluminum electrode to the nickel, or from the nickel electrode to the aluminum. Let's inspect table J to assist us with that. Now we're looking for aluminum and nickel. And where are they? Let me make this a little larger. Here we have aluminum, and here we have nickel. And here's how we figure it out. Aluminum is more reactive. It will lose electrons more easily because it's a metal to the nickel. So the aluminum, or the electrons, will flow from aluminum to nickel. And that's exactly what you state. The electrons will flow from aluminum to nickel. Alright, we're at the home stretch. Questions 23 to 25 relate to this scenario. And it says, the diagram below represents an operating electrolytic cell used to plate silver onto a nickel key. As the cell operates, oxidation occurs at the silver electrode, and the mass of the silver electrode decreases. The question for 23 says, explain in terms of silver atoms and silver plus aqueous ions why the mass of the silver electrode decreases as the cell operates. Well, let's confirm some things first. First of all, we do have a silver electrode and a nickel key. In which direction will electrons flow? Let's take a look, and it's silver and nickel. We have right here silver. Where is it? Silver is right here, and nickel is right here. Electrons would want to go from nickel to silver, but that doesn't happen when we add a battery. When we add a battery, electrons will go from silver to nickel. Alright, so now that we've confirmed that, let's diagram it. Okay, so the electrons are going to go from the silver electrode through this wire to the nickel key. Alright, let me take that off of there. And in doing that, we are going to form silver ions. This silver electrode itself is going to break up. The electrons are going to flow through the wire, leaving behind silver Ag plus in the solution, hoping to join the key and plate the key when the electrons arrive there. So the best answer to this, let me disclose it, is right here. Pause it so that you can read this. Let's move on to the next one now. Number 24. State the purpose of the power source in the cell. For this one, I'm just going to disclose the answer. Go ahead, read it, take notes on it, and if you do not understand it, please bring me your questions to class. So here is the answer for that. And let me get this one out of the way so you can read it more clearly. All right. Take note of what I wrote here. Again, if you do not understand it, bring information to me in class or send me a note through Edmodo. Number 25. Same scenario, but now we have to identify the cathode. For that, let's refer back to our trusted mnemonic of red cat and ox, where red stands for reduction, cat stands for cathode, so reduction happens at the cathode. That's what we're looking for. But remember, anox means the anode is where oxidation occurs. So where are we going to have reduction occurring? Well, we know from the previous slides that at this electrode, we're going to be liberating the electrons to go through the wire and land at the key, which is made out of nickel. So where's the cathode? The cathode is the key, which is made out of nickel. So you would be able to say that the key is the cathode, or the nickel solid is the cathode. Either one works. And lastly, let's take a closer look at why they say this is electroplating. Now, this bar here, again, is silver, and it's going to be losing electrons. So what is going to be happening there? When the silver, which was this, loses electrons, it becomes silver with a positive charge. Now those electrons are going to be traveling through this wire and arriving here, only to be able to give the electrons back to this silver. Now when that happens, when this silver takes those electrons back, it starts adhering to the surface of the key. So now we end up with a very thin but complete coating of silver around that key. You won't be able to see the nickel, unless, of course, in using the key, it eventually rubs off. Then it will be exposed again. But this is how they electroplate. Once again, let's run through it. Okay, let's use another color here. The electrons from this silver here will run through the wire, land at the nickel, and be available to attach to the silver ions that were once part of that electrode that lost the electrons to begin with. I hope this helped.